Lesson 12.7, Effect of Outliers. In today's lesson, we're going to discuss how does an outlier affect measures of center. Last time we met, we talked about mean, median, and mode. And to help us find measures of center, mean, we take all of our data and we average it together. Median is the number that's in the middle when I order the data from least to greatest. And mode is the number that occurs the most. So thinking of mean, median, and mode, we're going to discuss how an outlier can affect those three centers of measure. What we have here is a table with our data that's collected right here, and they've already taken this data and they've placed it into a dot plot so we can visually see all the responses. So if I look at the information above, the table gives the number of days that the 24 members of the Garfield Middle School volleyball team were absent from school last year. Does the data contain any outliers? So an outlier is a number that is either that's less than the set of numbers that we see the most, or it's a lot more. And if I look at my dot plot, I can identify the outlier is right here. It is 16. And I can see that because the rest of my data is all within this section of the dot plot. And so in this case, my outlier would be 16. Well, it's important to identify the outlier because it really can affect our mean and our median. So let's take a look at another example, and we're going to start it from the very beginning. So the high temperatures for the week in Foxdale in degrees Fahrenheit were 43, 43, 45, 42, 26, 43, and 45. The mean of the data is 41 degrees Fahrenheit, and the median is 43 degrees Fahrenheit. Identify the outlier and describe how the mean and median are affected by it. So the first thing I'm going to do is create a simple dot plot. And so I'm going to go through here. I have a 43, another 43, we have a 45, we have a 42, we have a 26, we have another 43, and we have another 45. Okay, so I can see that our outlier in this case is going to be 26. So they've already calculated the mean, which they said is 43, and the median, the mean is 41 and the median is 43. And so now what I'm going to do is take that outlier out and see how that affects my mean and my median. All right. So we're going to go over here. So now I want to try it without it. And so let me go ahead. The numbers were 42, 43, 43, 43, 45, and 45. All right. So 42 plus 43. I'm just going to simply add them all up. To get my new total. All right, so I have 261, so that's my total. And there are 1, 2, 3, 4, 5, 6 numbers, so I have to divide it by that. And I'm simply going to go ahead and divide. Bring down a 0. All right, so my new mean is 43 and a half. So if I look at it, the mean with the outlier is, and they said it was 41, and the mean without the outlier is 43 and a half. The outlier made the mean decrease because 41 is smaller than 43 and a half. All right, so now let's do the same thing and we're going to take a look at our median. So the median is a number that's right in the middle based on our data organized from least to greatest. And so again, I'm going to write my numbers down without the outlier. So we start at 42, 43, 43, 43, 45, and 45. And I'm simply going to go from the outside and work my way in. So, and I have an even number, so I see 43 and 43 in the middle. So if my two middle numbers are exactly the same, then that's what my median is. And so in this case, when I take a look at it, the median with the outlier was also 43, and without it is 43. And so the outlier did not affect the median in this case. All right, so what you're going to do now is you're going to have a worksheet to complete and you're going to be identifying the outlier in a set of data. You're going to be creating dot plots to assist you, and then you're going to answer the questions to see how the median and the mean has been changed due to the outlier. I look forward to discussing this with you more in class.